Hello, everyone. Welcome to this public lecture. My name is Eugene Nagasawa. I'm professor of philosophy and co-director of the John Hick Center for Philosophy of Religion at the University of Birmingham. I'm one of the organizers of this event. It's my great pleasure and great honor to introduce Professor William Lane Craig tonight. Professor Craig is currently research professor of philosophy at Talbot School of Theology and professor of philosophy at Houston Baptist University. He did his PhD at the University of Birmingham under the supervision of the late John Hick. Professor Craig has published over 30 books, including The Kalam Cosmological Argument, Time and Eternity, and Reasonable Faith. He has also authored more than 100 articles in professional journals, including the Journal of Philosophy, New Testament Studies, and the British Journal for Philosophy of Science. Professor Craig is now recognized as one of the most influential philosophers of religion. The topic of Professor Craig's lecture tonight is the Kalam Cosmological Argument, which was originally introduced by medieval Islamic theologians. Professor Craig has developed a contemporary version of this argument and significantly strengthened the argument by incorporating contemporary Big Bang cosmology and the mathematics of infinity. The Kalam Cosmological Argument is now one of the most discussed arguments for the existence of God. Ladies and gentlemen, please welcome Professor William Lane Craig.
Thank you very much. Thank you very much. I have so enjoyed delivering the Cadbury lectures this week at the University of Birmingham, and was delighted that Professor Nagasawa invited me to give this public lecture on the Kalam Cosmological Argument as well. And I'm looking forward to a stimulating evening together. As a boy, I wondered at the existence of the universe. I wondered where it came from. Did it have a beginning? Has it always existed? I remember lying in bed at night trying to think of a beginningless universe. Every event would be preceded by another event, back and back into the past, with no stopping point, or more accurately, no starting point. An infinite past with no beginning. My mind reeled at the prospect. It just seemed to me inconceivable. There must have been a beginning at some point, I thought, in order for everything to get started. Little did I suspect that for centuries, millennia really, men had grappled with the idea of an infinite past and the question of whether there was a beginning of the universe. Ancient Greek philosophers believed that matter was necessary and uncreated, and therefore eternal. God may be responsible for introducing order into the cosmos, but he did not create the universe itself. This Greek view was in contrast to even more ancient Jewish thinking about the subject. Hebrew writers held that the universe has not always existed, but was created by God at some point in the past. As the first verse of the Hebrew Holy Scriptures states, "In the beginning, God created the heavens and the earth," Genesis 1:1. Eventually, these two competing traditions began to interact. There arose within Western philosophy an ongoing debate that lasted for well over 1,000 years about whether or not the universe had a beginning. This debate played itself out among Jews and Muslims, as well as Christians, both Catholic and Protestant. It finally sputtered to something of an inconclusive end in the thought of the great 18th century German philosopher Immanuel Kant. He held, ironically, that there are rationally compelling arguments on both sides, thereby exposing the bankruptcy of reason itself. I first became aware of this debate only after graduating from university. Wanting to come to terms with this question, I decided upon the completion of my master's degree work in philosophy to find someone who would be willing to supervise a doctoral thesis on this question. The person who stood out above all others was Professor John Hick at the University of Birmingham. And we did come to Birmingham, and I did write on the cosmological argument under Professor Hick's direction. And eventually 3 books flowed out of that doctoral thesis. I was able to explore the historical roots of the argument, as well as deepen and advance the analysis of the argument. I also discovered quite amazing connections to contemporary astronomy and astrophysics. Because of the historic roots in medieval Islamic theology, I christened the argument the Kalam cosmological argument. Kalam is the Arabic word for medieval theology. Today, this argument, largely forgotten since the time of Kant, is once again back at center stage. The Cambridge Companion to Atheism in 2007 reports, account of the articles in the philosophy journals shows that more articles have been published about the Kalam argument that have been published about any other contemporary formulation of an argument for God's existence. Theists and atheists alike cannot leave the Kalam argument alone. What is the argument that has stirred such interest? Well, let's allow one of the greatest medieval protagonists in this debate to speak for himself. Al-Ghazali was a 12th century Muslim theologian from Persia, or modern-day Iran. He was concerned that Muslim philosophers of his day were being influenced by ancient Greek philosophy to deny God's creation of the universe. After thoroughly studying the writings of these philosophers, Ghazali wrote a withering critique of their views entitled The Incoherence of the Philosophers. In this fascinating book, he argues that the idea of a beginningless universe is absurd. The universe must have had a beginning, and since nothing begins to exist without a cause, there must be a transcendent creator of the universe. Ghazali formulates his argument very simply. I quote, "Every being which begins has a cause for its beginning. Now the world is a being which begins, therefore it possesses a cause for its beginning." Ghazali's reasoning involves 3 simple steps. Premise 1, whatever begins to exist has a cause of its beginning. Premise 2, the universe began to exist, from which it follows 3, therefore the universe has a cause of its beginning. Let's look at each premise of this argument. Notice that Ghazali does not need a premise so strong as 1 in order for his argument to succeed. The first premise can be stated more modestly as 1 prime. If the universe began to exist, then the universe has a cause of its beginning. This more modest version of the first premise will enable us to avoid distractions about whether subatomic particles, which are the result of quantum decay processes, come into being without a cause. For this alleged exception to premise 1 is irrelevant to 1 prime. For the universe comprises all contiguous space-time reality. Therefore, for the whole universe to come into being without a cause is to come into being from nothing, which is absurd. In quantum decay events, by contrast, the particles do not come into being from nothing. As Christopher Isham, Britain's premier quantum cosmologist, cautions, care is needed when using the word creation in a physical context. One familiar example is the creation of elementary particles in an accelerator. However, what occurs in this situation is the conversion of one type of matter into another, with the total amount of energy being preserved in the process. Thus, this alleged exception to 1 is not an exception to 1 prime. Let me give 3 reasons in support of premise 1 prime. First, something cannot come from nothing. To claim that something can come into being from nothing is worse than magic. When a magician pulls a rabbit out of a hat, at least you've got the magician, not to mention the hat. But if you deny premise 1 prime, you've got to think that the whole universe just appeared at some point in the past for no reason whatsoever. But nobody sincerely believes that things, say a horse or an Eskimo village, can just pop into being without a cause. Second, if something can come into being from nothing, then it becomes inexplicable why just anything and everything doesn't come into being from nothing. Think about it. Why don't bicycles and Beethoven and root beer come into being out of nothing? Why is it only universes that can come into being from nothing? What makes nothingness so discriminatory? There can't be anything about nothingness that favors universes, for nothingness doesn't have any properties, nor can anything constrain nothingness, since there isn't anything to be constrained. Thirdly, common experience and scientific evidence confirm the truth of premise 1 prime. The science of cosmogony is based on the assumption that there are causal conditions for the origin of the universe. So it's hard to understand how anyone committed to modern science could deny that 1 prime is more plausibly true than false. So I think that the first premise of the Kalam cosmological argument is surely true. The more controversial premise in the argument is premise 2, that the universe began to exist. This is by no means obvious. So let's examine both philosophical arguments and scientific evidence in support of premise 2. First, the philosophical arguments. Ghazali argued that if the universe never began to exist, then there has been an infinite number of past events prior to today. But, he argued, an infinite number of things cannot exist. Ghazali recognized that a potentially infinite number of things could exist, but he denied that an actually infinite number of things could exist. When we say that something is potentially infinite, infinity serves merely as an ideal limit which is never reached. For example, you could divide any finite distance in half, then into fourths, then into eighths, then into sixteenths, and so on to infinity. The number of divisions is potentially infinite in the sense that you could go on dividing endlessly, but you would never arrive at an infinity-f division. You would never have an actually infinite number of parts or divisions. Now, Ghazali has no problem with the existence of a merely potential infinite, for these are just ideal limits. But he argued that if an actually infinite number of things could exist, then various absurdities would result. If we're to avoid these absurdities, then we must deny that an actually infinite number of things exist. That implies that the number of past events cannot be actually infinite. Therefore, the universe cannot be beginningless. Rather, the universe began to exist. It's very frequently alleged that this kind of argument has been invalidated by developments in modern mathematics. In modern set theory, the use of actually infinite sets is commonplace. For example, the set of natural numbers, 0, 1, 2, 3, and so on, has an actually infinite number of members in it. The number of members in this set is not merely potentially infinite, according to modern set theory. Rather, the number of members is actually infinite. Many people have inferred that these developments undermine Ghazali's argument. But is that really the case? Modern set theory shows that if you adopt certain axioms and rules, then you can talk about actually infinite collections in a consistent way without contradicting yourself. All this accomplishes is showing how to set up a certain universe of discourse for talking consistently about actual infinites. But it does absolutely nothing to show that such mathematical entities really exist or that an actually infinite number of things can really exist. If Ghazali is right, this universe of discourse may be regarded as just a fictional realm, like the world of Sherlock Holmes, or something that exists only in your mind. The way in which Ghazali brings out the real impossibility of an actually infinite number of things is by imagining what it would be like if such a collection could exist, and then drawing out the absurd consequences. Let me use one of my favorite illustrations called Hilbert's Hotel, which is the brainchild of the great German mathematician David Hilbert. Hilbert first invites us to imagine an ordinary hotel with a finite number of rooms. Suppose, furthermore, that all the rooms are full. If a new guest shows up at the front desk asking for a room, the manager says, "Sorry, all the rooms are full." And that's the end of the story. But now, says Hilbert, let's imagine a hotel with an infinite number of rooms. And let's suppose, once again, that all the rooms are full. This fact must be clearly appreciated. There is not a single vacancy throughout the entire infinite hotel. Every room already has a real flesh and blood person in it. Now, suppose a new guest shows up at the front desk asking for a room. "No problem," says the manager. And he moves the person who was staying in room 1 into room 2. The person who was staying in room 2 into room 3. The person who was staying in room 3 into room 4, and so on out to infinity. As a result of these room changes, room number 1 now becomes vacant, and the new guest gratefully checks in. But before he arrived, all the rooms were already full. It gets worse. Let's now suppose, Hilbert says, that an infinity of new guests shows up at the front desk asking for rooms. "No problem," says the manager. And he moves the person who was staying in room 1 into room 2. The person who was staying in room 2 into room 4. The person who was staying in room 3 into room 6, and so on, each time moving the person into the room numbered twice his own. Since any number multiplied by 2 is an even number, all the guests wind up in the even-numbered rooms. As a result, all of the odd-numbered rooms become vacant, and the infinity of new guests is easily accommodated. In fact, the manager could do this an infinite number of times and always accommodate infinitely more guests. And yet, before they arrived, all the rooms were already full. As a student once remarked to me, Hilbert's Hotel, if it could exist, would have to have a sign posted outside, "No vacancy, guests welcome." Can such a hotel exist in reality? Hilbert's Hotel is absurd. Since nothing hangs on the illustrations involving a hotel, the argument can be generalized to show that the existence of an actually infinite number of things is absurd. Sometimes students react to Hilbert's Hotel by saying that these absurdities result because the concept of infinity is beyond us and we can't understand it. But this reaction is mistaken and naive. As I said, infinite set theory is a highly developed and well-understood branch of modern mathematics. The absurdities result precisely because we do understand the nature of the actual infinite. Hilbert was a smart guy, and he knew well how to illustrate the bizarre consequences of the existence of an actually infinite number of things. Really, the only thing the critic can do at this point is to just bite the bullet and say that a Hilbert's Hotel is not absurd. Sometimes critics will try to justify this move by saying that if an actual infinite could exist, then such situations are exactly what we should expect. But this response is inadequate. Hilbert would of course agree that if an actual infinite could exist, the absurdities with the imaginary hotel would be what one would expect. Otherwise, it wouldn't be a good illustration. But the question is whether such a hotel really is possible. So I think that Ghazali's first argument is a good one. It shows that the number of past events must be finite. Therefore, the universe must have had a beginning. We can summarize Ghazali's argument as follows. Premise 1, an actual infinite cannot exist. 2, an infinite temporal regress of events is an actual infinite. 3, therefore, an infinite temporal regress of events cannot exist. In addition to this argument, Ghazali has a second, independent argument for the beginning of the universe. The series of past events, Ghazali observes, has been formed by adding one event after another. The series of past events is like a sequence of dominoes, falling one after another until the last domino, today, is reached. But, he argues, no series which is formed by adding one member after another can be actually infinite, for you cannot pass through an infinite number of elements one at a time. This is easy to see in the case of trying to count to infinity. No matter how high you count, there is always an infinity of numbers left to count. But if you can't count to infinity, how could you count down from infinity? This would be like someone's claiming to have counted down all the negative numbers ending at 0. -3, -2, -1, 0. This seems crazy. For before he could count 0, he would have to count -1. And before he could count -1, he would have to count -2. Before he could count -2, he would have to count -3, and so on, back to infinity. Before any number could be counted, an infinity of numbers would have to have been counted first. You just get driven back and back into the past so that no number could ever be counted. But then the final domino could never fall if an infinite number of dominoes had to fall first. So today could never be reached. But obviously, here we are. This shows that the series of past events must be finite and have a beginning. Ghazali thought to heighten the impossibility of forming an infinite past by giving illustrations of the absurdities that would result if it could be done. For example, suppose that for every one orbit that Saturn completes around the sun, Jupiter completes 2. The longer they orbit, the farther Saturn falls behind. If they continue to orbit forever, they will approach a limit at which Saturn is infinitely far behind Jupiter. Of course, they will never actually arrive at this limit. But now turn the story around. Suppose Jupiter and Saturn have been orbiting the sun from eternity past, which will have completed the most orbits. The answer is that the number of their orbits is exactly the same, infinity. And we can't slip out of this argument by saying that infinity is not a number. In modern mathematics, it is a number. It is the number of elements in the set 0, 1, 2, 3, and so on. But that seems absurd. For the longer the orbit, the greater the disparity grows. So how does the number of orbits magically become equal by making them orbit from eternity past? Another illustration. Suppose we meet someone who claims to have been counting down from eternity past and is now finishing. -3, -2, -1, 0. Why, we may ask, is he just finishing his countdown today? Why didn't he finish yesterday? Or the day before that? After all, by then, an infinite amount of time had already elapsed. So if the man were counting at the rate of 1 number per second, he's already had an infinite number of seconds to finish his countdown. He should already be done. In fact, at any point in the past, he has already had infinite time, and so should already have finished. But then, at no point in the past can we find the man finishing his countdown, which contradicts the hypothesis that he has been counting from eternity past. Alexander Pruss and Robert Koons have recently defended an engaging contemporary version of Ghazali's argument called the Grim Reaper paradox. Imagine that there are infinitely many Grim Reapers who are bent on your destruction. You are alive at midnight. Grim Reaper number 1 will strike you dead at 1 a.m. if you are still alive at that time. Grim Reaper number 2 will strike you dead at 12:30 a.m. if you are still alive then. Grim Reaper number 3 will strike you dead at 12:15 a.m., and so on. Such a situation seems clearly conceivable given the possibility of an actually infinite number of things, but it leads to an impossibility. You cannot survive past midnight, and yet you cannot be killed by any Grim Reaper at any time. Pruss and Koons show how to reformulate the paradox so that the Grim Reapers are spread out over infinite time rather than over a single hour. For example, by having every Grim Reaper swing his scythe on January 1st of each past year if you have managed to live that long. These illustrations only strengthen Ghazali's claim that no series which is formed by adding one member after another can be actually infinite. Since the series of past events has been formed by adding one member after another, it can't be actually infinite. It must have had a beginning. And so we have a second good argument for premise 2, that the universe began to exist. We can summarize this argument as follows. 1, a collection formed by successive addition cannot be an actual infinite. 2, the temporal series of events is a collection formed by successive addition. 3, therefore, the temporal series of events cannot be an actual infinite. One of the most astonishing developments of modern astronomy, which Ghazali could never have anticipated, is that we now have strong scientific evidence as well for the beginning of the universe. The first scientific confirmation of the universe's beginning comes from the expansion of the universe. All throughout history, men have assumed that the universe as a whole was unchanging. Of course, things in the universe were moving about and changing, but the universe itself was just there, so to speak. This was also Albert Einstein's assumption when he first began to apply his new theory of gravity, called the general theory of relativity, to the universe in 1917. But Einstein found that there was something terribly amiss. His equations described a universe which was either blowing up like a balloon or else collapsing in upon itself. During the 1920s, the Russian mathematician Alexander Friedmann and the Belgian astronomer Georges Lemaître decided to take Einstein's equations at face value, and as a result, they came up independently with models of an expanding universe. In 1929, the American astronomer Edwin Hubble, through tireless observations at Mount Wilson Observatory, made a startling discovery which verified Friedmann and Lemaître's theory. He found that the light from distant galaxies appears to be redder than expected. This red shift in the light was most plausibly due to the stretching of the light waves as the galaxies are moving away from us. Wherever Hubble trained his telescope in the night sky, he observed this same red shift in the light from the galaxies. It appeared that we are at the center of a cosmic explosion, and all the other galaxies are flying away from us at fantastic speeds. Now, according to the Friedmann-Lemaître model, we're not really at the center of the universe. Rather, an observer in any galaxy will look out and see the other galaxies receding from him. This is because, according to the theory, it is really space itself which is expanding. The galaxies are actually at rest in space, but they recede from one another as space itself expands. The Friedmann-Lemaître model eventually came to be known as the Big Bang theory. But that name can be misleading. Thinking of the expansion of the universe as a sort of explosion could mislead us into thinking that the galaxies are moving out into a pre-existing empty space from a central point. That would be a complete misunderstanding of the model. The theory is much more radical than that. As you trace the expansion of the universe back in time, everything gets closer and closer together. Eventually, the distance between any 2 points in space becomes zero. You can't get any closer than that. So at that point, you've reached the boundary of space and time. Space and time cannot be extended any further back than that. It is literally the beginning of space and time. To get a picture of this, we can portray our three-dimensional space as a two-dimensional disk which shrinks as you go back in time. Eventually, the distance between any 2 points in space becomes zero. So, space-time can be represented geometrically as a cone. What's significant about this is that while a cone can be extended indefinitely in one direction, it has a boundary point in the other direction. Because this direction represents time and the boundary point lies in the past, the model implies that past time is finite and had a beginning. Because space-time is the arena in which all matter and energy exist, the beginning of space-time is also the beginning of all matter and energy. It's the beginning of the universe. Notice that there's simply nothing prior to the initial boundary of space-time. Let's not be misled by words, however. When cosmologists say there is nothing prior to the initial singularity, they do not mean that there is a state of affairs prior to it, and that is a state of nothingness. That would be to treat nothing as though it were something. Rather, they mean that at that boundary point, it is false that there is something prior to this point. The standard Big Bang model thus predicts an absolute beginning to the universe. If this model is correct, then we have amazing scientific confirmation of the second premise of the Kalam cosmological argument. So, is the model correct? Or more importantly, is it correct in predicting a beginning of the universe? Despite its empirical confirmation, the standard Big Bang model will need to be modified in various ways. The model is based, as we've seen, on Einstein's general theory of relativity. But Einstein's theory breaks down when space is shrunk down to subatomic proportions. We'll need to introduce subatomic physics at that point, and no one is sure how this is to be done. Moreover, the expansion of the universe is probably not constant, as in the standard model. It's probably accelerating and may have had a brief moment of super rapid expansion in the past. But none of these adjustments need affect the fundamental prediction of the absolute beginning of the universe. Indeed, physicists have proposed scores of alternative models over the decades since Friedman and Lemaitre's work, and those that do not have an absolute beginning have been repeatedly shown to be unworkable. Put more positively, the only viable non-standard models have been those that involve an absolute beginning to the universe. That beginning may or may not involve a beginning point, but on theories such as Stephen Hawking's no-boundary proposal that do not have a point-like beginning, the past is still finite, not infinite. The universe has not existed forever, according to such theories, but came into existence even if it didn't do so at a sharply defined point. In a sense, the history of 20th century cosmology can be seen as a series of one failed attempt after another to avoid the absolute beginning predicted by the standard Big Bang model. That prediction has now stood for nearly 100 years during a period of enormous advances in observational astronomy and creative theoretical work in astrophysics. Meanwhile, a series of remarkable singularity theorems has increasingly tightened the loop around empirically tenable models by showing that under more and more generalized conditions, a beginning is inevitable. In 2003, Arvind Borde, Alan Guth, and Alexander Vilenkin were able to show that any universe, which is on average in a state of cosmic expansion throughout its history, cannot be infinite in the past, but must have a beginning. That goes for multiverse scenarios as well. In 2012, Vilenkin showed that models which do not meet this one condition still fail for other reasons to avert the beginning of the universe. Vilenkin concluded, and I quote, "None of these scenarios can actually be past eternal. All the evidence we have says that the universe had a beginning." The Borde-Guth-Vilenkin theorem proves that classical space-time, under a single very general condition, cannot be extended to past infinity, but must reach a boundary at some time in the finite past. Now, either there was something on the other side of that boundary or not. If not, then that boundary just is the beginning of the universe. If there was something on the other side, then it will be a region described by the yet-to-be-discovered theory of quantum gravity. In that case, Vilenkin says, it will be the beginning of the universe. Either way, the universe began to exist. Now, of course, scientific results are always provisional. We can fully expect that new theories will be proposed, attempting to avoid the universe's beginning. Such proposals are to be welcomed and tested. Nevertheless, it's pretty clear which way the evidence points. Today, the proponent of Ghazali's cosmological argument stands comfortably within the scientific mainstream in holding that the universe began to exist. As if this weren't enough, there's actually a second scientific confirmation of the beginning of the universe, this one from the second law of thermodynamics. According to the second law, unless energy is being fed into a system, the system will become increasingly disorderly. Now, already in the 19th century, scientists realized that the second law implied a grim prediction for the future of the universe. Given enough time, all the energy in the universe will spread itself out evenly throughout the universe. The universe will become a featureless soup in which no life is possible. Once the universe reaches such a state, no significant further change is possible. It is a state of equilibrium. Scientists called this the heat death of the universe. But this unwelcome prediction raised a further puzzle. If given enough time, the universe will inevitably stagnate in a state of heat death, then why, if it has existed forever, is it not now in a state of heat death? If in a finite amount of time the universe will reach equilibrium, then given infinite past time, it should by now already be in a state of equilibrium. But it's not. We're in a state of disequilibrium, where energy is still available to be used, and the universe has an orderly structure. The 19th century Austrian physicist Ludwig Boltzmann proposed a daring solution to this problem. Boltzmann suggested that perhaps the universe is, in fact, in a state of overall equilibrium. Nevertheless, by chance alone, there will arise more orderly pockets of disequilibrium here and there. Boltzmann referred to these isolated regions of disequilibrium as worlds. Our universe just happens to be one of these worlds. Eventually, in accord with the second law, it will revert to the overall state of equilibrium. Contemporary physicists have universally rejected Boltzmann's daring many worlds hypothesis as an explanation of the observed disequilibrium in the universe. Its fatal flaw was that if our world is just a chance fluctuation from a state of overall equilibrium, then we ought to be observing a much smaller patch of order. Why? Because a small fluctuation from equilibrium is vastly more probable than a huge, sustained fluctuation which would be necessary to create the universe we see. And yet a small fluctuation would be sufficient for our existence. For example, a fluctuation that formed a world no bigger than our solar system would be enough for us to be alive and would be incomprehensibly more likely to occur than a fluctuation that formed the whole universe we see. In fact, Boltzmann's hypothesis, if consistently carried out, would lead to a strange sort of illusionism. In all probability, we really do inhabit a smaller world, and the stars and the planets that we observe are just illusions, mere images on the heavens. For that sort of world is much more probable than a universe which has, in defiance of the second law of thermodynamics, moved away from equilibrium for billions of years to form the universe we observe. The discovery of the expansion of the universe in the 1920s modified the sort of heat death predicted on the basis of the second law, but it didn't alter the fundamental question. Recent discoveries indicate that the cosmic expansion is actually speeding up. Because the volume of space is increasing so rapidly, the universe actually becomes farther and farther from equilibrium, an equilibrium state in which matter and energy are evenly distributed. But the acceleration of the universe's expansion only hastens its demise. For now, the different regions of the universe become increasingly isolated from one another in space, and each marooned region becomes dark, cold, dilute, and dead. So again, why isn't our region in such a state if the universe has already existed for infinite time? The obvious implication of all this is that the question is based on a false assumption, namely that the universe has existed for infinite time. Today, most physicists would say that the matter and energy were simply put into the universe as an initial condition, and the universe has been following the path plotted by the second law ever since its beginning a finite time ago. Of course, attempts have been made to avoid the beginning of the universe, predicted on the basis of the second law of thermodynamics, but none of them has been successful. Skeptics might hold out hope that quantum gravity will somehow serve to avert the implications of the second law of thermodynamics. But in 2013, the cosmologist Aaron Wall of the University of California was able to formulate a new singularity theorem which seems to close the door on that possibility. Wall shows that given the validity of the generalized second law of thermodynamics in quantum gravity, the universe must have begun to exist unless one postulates a reversal of the arrow of time. That is to say, time runs backwards at some point in the past, which, he rightly observes, involves a thermodynamic beginning in time, which would seem to raise the same sorts of philosophical questions that any other sort of beginning in time would. Wall reports that his results require the validity of only certain basic concepts, so that it is reasonable to believe that the results will hold in a complete theory of quantum gravity. So, once again, the scientific evidence confirms the truth of the second premise of Ghazali's cosmological argument. On the basis, therefore, of both philosophical and scientific evidence, we have good grounds for believing that the universe began to exist. It therefore follows logically that the universe has a cause of its beginning. What properties must this cause of the universe possess? This cause must itself be uncaused, because we've seen that an infinite series of causes is impossible. It is therefore the uncaused first cause. It must transcend space and time, since it created space and time. Therefore, it must be immaterial and non-physical. It must be unimaginably powerful, since it created all matter and energy. Finally, Ghazali argued that this uncaused first cause must also be a personal being, for it's the only way to explain how an eternal cause can produce an effect with a beginning like the universe. Here's the problem. If a cause is sufficient to produce its effect, then if the cause is there, the effect must be there too. For example, the cause of water's freezing is the temperatures being below 0 degrees Celsius. If the temperature were below 0 degrees from eternity, then any water that was around would be frozen from eternity. It would be impossible for the water just to begin to freeze a finite time ago. Now, the cause of the universe is permanently there, since it is timeless. So why isn't the universe permanently there as well? Why did the universe come into being only 14 billion years ago? Why isn't it as permanent as its cause? Ghazali maintained that the answer to this problem is that the first cause must be a personal being, endowed with freedom of the will. His creating the universe is a free act, which is independent of any prior determining conditions. So his act of creating can be something spontaneous and new. Freedom of the will enables one to get an effect with a beginning from a permanent, timeless cause. And thus we are brought not merely to a transcendent cause of the universe, but to its personal creator. This is admittedly hard for us to imagine, but one way to think about it is to envision the creator existing alone without the universe as changeless and timeless. His free act of creation is a temporal event simultaneous with the universe's coming into being. Therefore, he enters into time when he creates the universe. The creator is thus timeless without the universe and in time with the universe. The Kalam cosmological argument thus gives us powerful grounds for believing in the existence of a beginningless, uncaused, timeless, spaceless, changeless, immaterial, enormously powerful, personal creator of the universe. And that is what everybody means by God.
Thank you so much for the most intellectually stimulating lecture. Now, I would like to open a Q&A session. This is a great opportunity for you to ask Professor Craig a question. We would like to start from the back over there. So if you have any questions, please raise your hand.
Hi, Dr. Craig. Thanks very much. It was a fascinating talk, and very, very clear as well. You seem to suggest, and it seems quite obvious to say, that either the universe went back forever or it didn't. And yet, a number of people say that the Big Bang wasn't the beginning of the universe, or wasn't the beginning of everything. There was something that caused the Big Bang, or there was something that the Big Bang came out of. So you could call it some kind of quantum cauldron or quantum soup or something that the Big Bang came out of. This would itself not be temporal, because as I understand it, and I might be wrong, the time and space began with the beginning of the universe, with the Big Bang. And so the thing that the Big Bang came out of wasn't itself temporal. If that's the case, does it make any sense to talk about it going back forever? Because with no time, there's no back forever, as it were. And so maybe the distinction between either it began or it went back forever doesn't quite work there, or how would it work?
No, I think it does apply, and your point is quite well taken. If it literally is atemporal, then it doesn't go back forever. And that's why Vilenkin says either the universe begins at that boundary of classical space-time, or if you do have this sort of quantum regime on the other side of the boundary, that doesn't go back forever. And in, for example, the Hartle-Hawking model, you have this finite quantum region prior to the Planck time, early time in the history of the universe, that is finite and geometrically closed. Just like in the Standard Model, it doesn't involve a singularity. Now, this is where the philosopher, I think, does need to begin to offer criticism. Because when it is said that this region is not temporal, the scientist cannot mean that in the same literal sense that the philosopher means, for example, that mathematical objects are atemporal, changeless, and static. He can't mean it in the same sense that the theologian means that God is atemporal, transcending time. What the scientist actually means is that it isn't in classical time, as defined in non-quantum physics, but this is a region of violent quantum activity. There is before and after in this period. And so it cannot be literally timeless in the way that the philosopher or theologian means that. But in that case, this quantum era cannot have endured forever in a sort of metaphysical time because it's unstable. It would be impossible for this era to last for eternity and then 14 billion years ago transition to classical space-time. So I think this would just simply underline the point that that era doesn't restore the past eternality of the universe. It is something that still has a beginning in time, in the philosophical sense of the word, if not in the sense of the word that plays a role in classical physics. I know that's a rather technical answer, but this is pulling the thread on one of the most important issues, I think, in this whole discussion. If you're interested in following this up, take a look at the debate that I had with the cosmologist Sean Carroll. It's on YouTube, on the evidence of current cosmology for the existence of God.
Thank you.
As far as I understand it, the laws of cause and effect say that a cause cannot be greater than its effect and vice versa. So if God is the cause of the universe, surely he's a greater cause than its effect, if the universe is the effect.
Okay, I didn't quite understand that. Can you help me?
So I think the idea is that if God is the creator of the universe, then because God is the cause of the universe, it has to be greater than the universe itself.
Oh, okay. Now, as your question was explained to me, the idea is that a cause needs to be greater than its effect. And I would agree with that in this case, that we have to have a cause which is endowed with incomprehensible power in order to produce space, time, matter, and energy without any pre-existing material. So this would be a being which is, if not omnipotent, of incomprehensible power and greatness. So I think that's absolutely correct. This has to be something that is greater than the finite universe.
I was thinking through the idea, I believe that the creation, that the earth is a young earth. And I was trying to think about how that ties in your idea of the Big Bang, how that ties into my understanding. And so basically, my question is, when you come to Genesis chapter 1, verse 1, in the beginning, God created the heaven and the earth. In your view, is that the start of the creation of this earth, or is it the creation of the universe?
Good question. In Hebrew, they did not have a word for the universe. When the ancient Jew wanted to speak of everything there is, he would say the heavens and the earth. So Genesis 1:1 is about the creation of the universe. In the beginning, God created the universe. And it's only beginning with verse 2 that the focus dramatically narrows to the earth. And verse 2 says, and the earth was without form and void. And the remainder of the chapter describes how God turns this desolate planet into a habitable environment for human beings. So I would see verse 1 as cosmic in its scope, and verse 2 and following as very local in its scope.
And so could there be a gap of time?
We need to move on to other questioners if we're to get as many folks as possible in our limited time.
Hi, Dr. Craig. And why only one creator and not 10 or 1 million of creators? I don't see from your argument that could not have 1 million of creators.
Yes, why not several creators? Why not polytheism rather than one creator? I would appeal to Occam's razor. Occam's razor is an explanatory principle which says, do not multiply causes beyond necessity. That is to say, you are justified only in inferring those causes which are necessary to explain the effect, and you would be unjustified to infer any more than that. And in this case, one creator is sufficient to explain the effect and is necessary to explain the effect, and therefore Occam's razor will simply shave away any other sorts of creators.
Thank you very much for your great talk. Oh, sorry. In the last 30 years or so, it has been shown experimentally that in quantum mechanics you can have creation without a cause. You mentioned it, subatomic particles. And at the very beginning of the universe, as you also said, the universe itself was subatomic. why is it so inconceivable that the mechanisms that work now didn't work back then?
The reason is that in the so-called quantum creation of subatomic particles, you always have a material substratum, a physical system from which these emerge. For example, the quantum vacuum is not nothing, as the layman might think when he hears the word vacuum. It is a sea of roiling energy, and the particles come out of the vacuum, so that the vacuum is the cause of the existence of these particles. In the case of the universe, however, as we just discussed a moment ago, we have an absolute beginning of all physical reality, so that there isn't any sort of prior thing that could serve as a quantum substratum for the creation of the universe. If there is this sort of quantum gravity region in the early universe, that will be part of the universe. It's an early stage of the universe, but it doesn't explain where the universe itself came from. I should also just add one other point, and that is this appeal to these quantum processes simply assumes without justification that quantum indeterminacy is real rather than merely epistemic in your mind. But there are at least 10 different interpretations of quantum physics, some of which are thoroughly deterministic. And all of these are empirically equivalent and mathematically consistent. In fact, it is only the deterministic interpretations that are compatible with quantum cosmology, so that there is no justification for assuming that even in the case of quantum creation of particles, this is indeterminate and that they do not have deterministic causes.
What inspirations can one derive from religious texts such as Quran, where existence of God, whose teachings about existence of God are confirmed by philosophical arguments and scientific discoveries?
I've debated Muslim apologists on a number of occasions, and I'm not persuaded by those sorts of arguments for the divine inspiration of the Quran. For example, it said that the Quran predicts modern embryology because it says that we came from a clot of blood. Well, you can read this sort of thing in ancient medicine, ancient doctors like Galen. So there's not really anything there that I think amounts to a substantive argument. It's either reading in between the lines of the text, or I think the text is so vague that it could be interpreted in multiple ways. But that's quite off the topic of tonight, and I don't care to address the truth of the Quran any further.
I noticed there were just males sticking their hands up. Are there any ladies who'd like to ask a question? Ah, there we are. Hang on.
There's one.
Thank you for your talk. If you find the idea of an infinite universe so inconceivable, then why is the idea of an infinite being so, persuasive to you?
Okay, I'm going to need help with that one again.
If the concept of infinity cannot be applied to the universe, how could you apply it to God?
Okay. If the concept of infinity cannot be applied to the universe, how could it be applied to God? It's important to distinguish between what we might call a quantitative concept of the infinite and a qualitative concept of the infinite. I am talking in this lecture about quantitative concepts, mathematical concepts of the infinite, where the infinite is a collection composed of an infinite number of definite and discrete parts or members. When theologians talk about God's infinity, they're not using it in that sort of quantitative sense. They don't think that God is a collection composed of an infinite number of definite and discrete parts. Rather, what they mean is that God is omnipotent, omniscient, omnipresent, eternal, morally perfect, and so forth. All of these omni attributes. So the word infinite there is used in a qualitative sense, not a quantitative sense, to simply describe God's superlative attributes, and none of those involve the existence of an actual infinite number of things in the way that we've been discussing this evening.
Hello, Professor Craig. You explained to us in your very intriguing talk that every being that exists in the universe has a cause for its beginning, and that the agent that caused the universe's beginning is uncaused. But I was wondering whether or not perhaps the first premise might raise questions relating to how the agent exists, since everything that exists in the universe has a cause, and yet the agent that existed that created it is uncaused.
Okay, now I didn't get the very last part of that. Did
Are
you?
you asking whether the first premise applies to God?
The first premise certainly applies to God. If God began to exist, then God would need to have a cause. Otherwise, that would be special pleading. So what this premise gets you back to, as I say, is a first uncaused cause. The premise is not that everything that exists has a cause. It's that everything that begins to exist has a cause. Something cannot come into being without a cause. So it forces you back to what Al-Ghazali called it, the eternal, a timeless, transcendent cause without beginning, and therefore the first uncaused cause. Mm-hmm.
Thank you. Just to, again, put some pressure on that first premise, the skeptic might say, we never really experience anything beginning to exist. You take, for example, the example like a horse. You might say that the energy and matter necessary for the horse already exists. They just changed form, if you like. So the horse was formed rather than genuinely beginning to exist. And so experience confirms the idea there's always a cause for the formation of things, but common experience doesn't confirm that when matter and energy begin to exist, they have a cause. So the coming into being of matter and energy is unique and an event unlike any other in our experience, so it isn't covered by laws which we derive from our common experience.
This question is based upon a terrible misconception that if a thing has material constituents which preceded its existence, then the thing made of those constituents doesn't begin to exist. And that's clearly absurd. That would imply that I am an eternal being, that I never began to exist. So where was I during the Jurassic Age, I wonder? Where was I during the era of galaxy formation? Simply because things that begin to exist have material constituents of which they are composed doesn't mean that those things have existed eternally and are without beginning. So the whole question is based upon a misconception of what it means to begin to exist. Now, in the first premise, the premise doesn't stipulate what kind of cause there has to be for what begins to exist. It's just saying that something can't come into existence without some sort of a cause, a material cause, an efficient cause, whatever. The fact that the universe has an efficient cause but not a material cause only emerges when you get to the conclusion of the argument. And you see that as the cause of space and time, matter and energy, the cause of the universe cannot be a material object. It has to be a transcendent, immaterial being, like, for example, a mind, which brought the universe into existence. And that correlates nicely with Ghazali's argument that the creator is a personal being, an unembodied mind who freely creates the universe. And I think all three of the arguments that I gave would hold validly with respect to the necessity of such a cause of matter and energy, that something cannot come from nothing. If something could come from nothing, then it's inexplicable why just anything and everything doesn't do so. And then the everyday experience and science confirms that things that begin to exist do have causes. So it seems to me that the first premise is more plausibly true than false, and that's all we need for a good argument.
Professor Craig, it's a pleasure to have you speak here because I argued against your Kalam cosmological argument in my extended project, and I can finally confront you. So you seem to kind of cherry pick different theories, different physical and mathematical theories. You use the Borde-Guth-Vilenkin theorem in your favor, saying that there cannot be an infinite universe, but you fail to address the fact that the Borde-Guth-Vilenkin theorem says that virtual particles can materialize out of fluctuations in subatomic vacuum, and this behavior is completely random. An opponent of yours...
You're, I take it, kind of repeating things from your paper.
Yeah.
But these questions have already been addressed this evening, when both in the talk and in the answer to the questions at the back of the auditorium, where we said, yes, the Borde-Guth-Vilenkin theorem shows that classical space-time goes back to a boundary, right? And either there was something on the other side or not. If not, the boundary was the beginning of the universe. If there was, it was a quantum gravity era, and that is then the beginning of the universe. But in neither case do you get a universe that's extended infinitely into the past.
Keep in mind, this is a theory, and there are plenty of other theories. For example, you appeal to mathematics in many cases, but recently there's been a mathematical explanation how the universe did not have a beginning, but it was actually infinite. Paul Marmer, for example, states that the redshift is non-Doppler mechanics, and therefore it does not explain that there was one singularity 13.74 billion years ago where the universe was created. And nonetheless, why wasn't this preceded by another universe? For example, a big crunch.
Yeah, those models are ruled out by the sort of singularity theorems that I discussed this evening, as well as evidence that the universe doesn't have the density to recontract again, that the expansion is actually accelerating. If you want to look into a more detailed explanation, take a look at the article in the Blackwell Companion for Natural Theology on the Kalam cosmological argument that I co-authored with the physicist Jim Sinclair. And I think you'll find that the thrust of contemporary science is such that the person who holds to the truth of the second premise stands, as I said, well within the mainstream of modern science, whereas these other things that you mentioned would represent things on the fringe or things that have been already falsified. So I would just ask you to take a look at an article like that where one goes into more detail than what we've been able to do this evening.
My question is to do with the first premise with regards to entities beginning to exist without a cause, out of nothing. If we took a very simple definition of the term cause and said a cause simply is a collection of necessary conditions for any entity to begin to exist, and
it would need to be sufficient, right?
Yes.
Sufficient conditions.
Yes, sufficient conditions. Isn't one of the sufficient conditions for any entity to begin to exist the fact that it has to have a basis in reality? And therefore, if an entity can begin to exist uncaused, it means it's beginning to exist without fulfilling that condition of having to have a basis in reality. Then aren't we postulating entities that begin to exist without having any basis in reality, which sounds impossible or absurd, as you're saying?
Yes. Well, now, if I understood the question right, I would concur completely that it makes absolutely no sense to say that something could have been caused by an unreal being, something that doesn't really exist. Clearly, if there is a cause of the universe, it had to be something that really exists, not a fictional or imaginary entity. This needs to be real. So that's why this would be a strong argument for the reality of a first personal cause of the universe.
Good afternoon. I'm afraid I lost you on your argument about a personal being.
Yes.
Elaborating on a point that was made a little while earlier, you say that before the beginning, if you like, there would not be there would not have been even an eternal equilibrium without a personal being due to the cause being spontaneous. But surely by definition of something being atemporal, there would have been no eternity anyway. By definition, any cause...
The last part again, if something is atemporal...
If something is atemporal, there would have been no eternity. Surely by definition, any actual cause would have been spontaneous regardless of its nature.
Okay, I'm trying to understand your point. The idea here is that there is a cause of the universe which is timeless, eternal, and therefore permanent. And as this fellow down here said, if all of the sufficient, or if all the necessary conditions are in place, if you have the sufficient conditions for the effect in place permanently, then the cause should be there, or the effect should be there too. You can't have all the causal conditions sufficient for the effect without having the effect there. Otherwise, the conditions weren't truly sufficient. So how in the world do you get a cause that is permanent and sufficient, but an effect that only begins to exist a finite time ago? Ghazali argued, and here I think it's a brilliant insight, is that the only way to do this is if the cause of the universe is a person. That is to say, the appeal here is to agent causation. An agent who is endowed with freedom of the will can spontaneously produce an effect without any antecedent determining conditions. It's wholly independent of the antecedent determining conditions. And so freedom of the will is what makes it possible to have a timeless, permanent cause, and yet an effect that only begins to exist a finite time ago. And as I argued, I think that that moment at which this cause exercises its causal power and brings the universe into being is the moment at which that creator enters into time, so that the creator is timeless without the universe and in time from the moment of creation forwards.
Thank you. Hello, Dr. Craig. Going back to what you said about an actual infinite cannot exist, and that we can't split time and we can't split distance, could you say that because of the original beginning, we can't split the universe into an infinite amount of universes, so therefore the multiverse cannot exist because we can't split the universe into an actual amount of infinites?
I'm going to need some help with that one. I didn't quite understand.
I think maybe you misunderstood Professor Gray's argument.
Maybe. I'm just trying to ask if multiverses can exist.
Would you be able to rephrase your question?
Basically, I'm trying to ask is, because we can't have an actual infinite, can we not have an actual infinite of universes? Therefore, can we not have an...
Okay, I think the question is whether you reject the hypothesis of the multiverse.
Yeah,
because you reject
I think I understand now the point. It wouldn't rule out a multiverse that had a finite number of universes in the world ensemble. If you do agree that an actually infinite number of things cannot exist, then you're correct. You could not have a multiverse or world ensemble composed of an actually infinite number of multiverses. And physicists have sometimes expressed reservations precisely on that head, that this would involve an actually infinite number of universes. So you would need to have a multiverse that had at best finite, a large number of universes. But then, of course, the question is that going to be sufficient to explain the fine-tuning of the universe by chance alone, which is a different argument that is relevant to these multiverse proposals.
Why is the afterlife is supposed to be eternal? Why isn't it there yet?
Say again?
The afterlife is supposed to be eternal.
Right.
Why isn't it there yet when it's eternal?
Why isn't what eternal?
The afterlife.
Why isn't the afterlife? Okay, if I understand the question, theists or Christian theists like myself believe in the afterlife and that this life will go on forever without end. Wouldn't that involve an actually infinite number of events? No, and here the distinction between an actual infinite and a potential infinite is crucial. If time involves genuine becoming of things coming into being and passing away, as the argument presumes, then a beginningless series in the past would involve an actually infinite number of events that have occurred. But an endless future doesn't involve an actually infinite number of events, but merely a potentially infinite number of events. The events will go on and on endlessly, and infinity is merely a limit which it endlessly approaches but never arrives at. So on this view of time, the future is not actually infinite, it's merely potentially infinite, which is unproblematic.
Okay, let's take 2 more questions.
Dr. Craig, that was an excellent presentation tonight. Thank you.
Thank you.
So my question is, you said that creating something from nothing is absurd. I'm down here at the front.
Oh, there you are. Okay.
I can barely see your head over the thing.
Okay.
So you said that creating something from nothing is absurd. And so my question is, in the beginning, what did God create the universe from? And did that always exist?
Let's be very careful here. I didn't say that creation of something from nothing is absurd. When theologians talk about creation from nothing, they mean that the universe has an efficient cause, that is to say, an agent that brought it into existence, but it doesn't have a material cause. There is no stuff out of which it was made. I was arguing that something cannot come into being without any sort of cause, that is absurd. For something to come from nothing would be to come into being without any efficient cause or any material cause. And that seems to me to be truly absurd. But for something to come into being without a material cause, but an efficient cause, is not absurd, because there you do have causal conditions, causal power that brings the matter and energy into being. So it seems to me that there's an enormous difference there, and one has to be careful in distinguishing the type of causes that are in play here, efficient causes versus material causes.
Let's take the last question from the lady over there.
Okay then, so this is my favorite question. How then do we deal with the issue of we have a creator God and before time he wasn't, or he or she or whatever, was not a creator God. So we've got, by choosing God, spontaneously choosing to create, we have a change in God. And a change in God is very problematic.
I do not think that God is immutable. I think you're correct that this would involve a non-essential change in God. And I have written quite a number of books on God and time in which I explore this issue in enormous depth. And my view would be that when the Creator creates space and time, he becomes temporal in virtue of his real causal relationship to the world and in virtue of his knowledge of tensed facts, like it is now 2015, it was 2014. Both of those would imply, I think, at least extrinsic change in God and probably even intrinsic change. So I would say that God is changeless in his essential attributes, like his omnipotence, omniscience, moral perfection, eternality, and so forth. But he can change in contingent properties, like being the creator of the universe, knowing that Bill Craig is giving a lecture at the University of Birmingham. In all of these contingent properties, I think God is changing and that's unproblematic, both theologically and philosophically.
Right. Please join me in thanking